Hey all, it's Andrew Couch here, and in this Tidy Tuesday video, we're not going to be looking at this week's dataset. Instead, we're going to build upon our Tidymodels um, videos and do some more machine learning stuff. So I was going through the Tidymodels GitHub, and I saw that there was a stacks package, and this is a package for stacking your Tidymodels or doing some ensembling. So you'll usually see stacking or model ensembling in like competitions like Kaggle, where you're essentially combining separate machine learning models predictions and creating another model into it. So for example, this is like a nice little diagram of your models. You're using these models outcomes to predict the outcome. And these models can basically be represented as coefficients with like a lasso regression model. So it's cool that there's a package for this to make it a little bit more tidier and neater. So I thought it'd be kind of cool to do a short little video of creating an ensemble model using Tidymodels and the stacks package. I will also know that this is the unstable version, so you can't do install.packages. You have to do a remote install. Additionally, some of the functions may not be working or may change. So this is just kind of a basic intro to see what the stacks package is about and what we're trying to accomplish. So I'm going to load up a our markdown sheet. I'll call it Tidy Models Ensemble. Okay. And for this, since we're using this new package, I thought it'd be pretty smart to use the Ames Housing dataset. So I'm going to do Tidy Models, Tidyverse, Tidy Models, Ames Housing, and then the stacks package. Also paste this in just so you can use it, you can install it if you have not installed the package already. So then we'll do the make Ames. We can do a basic kind of glance at it. So just do a summary. We can see we have all this stuff. Since this data set is basically already cleaned for us, we don't have to really worry about it. And I figured we just make our seeds and our trains and test sets first. So I'll say train and test sets. So set.seed, it's the 13th. We'll do a tidy split. This is just a generic modeling procedure. So we're going to create a train and test split using our df. Prop is 80/20. So we'll do 80. 80. And then we'll make our tidy train. So training, tidy split, tidy test, which will be our testing tidy split. And then we'll create our k-folds data, which will be vfold cv. And we're going to use our training data set as our validation k-folds data set. So tidy train. Okay. So that's basic data partitioning, nothing crazy. And now we're going to go over kind of the main approaches for ensemble modeling. So one of the main things with ensemble modeling is you want your models to be different. It's generally not really, it doesn't really make a lot of sense to use like basically the same XGBoost models or ensembling. You want to have some diversity into it. So I figured we first kind of start with a basic pre-processing function. And I figured that a common model that's pretty simple is a Pca regression model. So it's just gonna be a linear regression model using Pca as a preprocessor. So we'll create our recipe. We're gonna be predicting sales price because it's the Ames Housing data set. We're gonna give it our train data. To our tidy train data. Okay. And then we're gonna probably do some basic preprocessing. Since if we look at our training data set, we have 81 columns with a bunch of factors, a bunch of continuous variables. So I figured we should do at least some data. We should remove some of these columns and do some dimensionality reduction. So first, I'm going to do a step near zero variance. And I'll say all predictors. So any predictors that basically have no variance in it will be removed. Then I'll do a step correlation, and say all numeric minus all outcomes, which will be removing any highly correlated variables. Okay, we're also going to do a step linear combination. So any linear combinations, which will remove some of our variables, hopefully. Okay, so this is basically our dimensionality reduction for our continuous variables. I also want to remove some of these classes. Some of these things, like if we look at subclass, we might have a so we have a bunch of factors for this, and I fear we would want to kind of reduce this, especially if we're doing like one hot encoding, etc. So what I'll do is step other and say all nominal. So in this case, if there's a minority class, it'll just convert it to other. So if it only shows up 3 out of the 500 times, it'll be converted to a other variable. Okay, so then what we're going to do is step normalize all numeric minus all outcomes, because we're going to be doing some PCA or principal components analysis. We're going to then dummy the variable, so all nominal or categorical. And lastly, we're going to do is step PCA, and we'll say all predictors. And for our components, we'll just use 5 components. Okay, so if we do our Pca Rec, prep it, we can see we do all of our pre-processing features. We have our dummy variables, our linear combinations. I guess it didn't find anything. It removed some sparse variables and some and it didn't remove any correlated variables, which is fine. So if we do our prep and our choose, we can see how it basically condenses it to 5 principal components to predict sale price. And that's going to be our linear, and we're going to throw this into a linear regression model and use that to predict sale price, where we're going to actually blend it in with some more models. Okay. The next thing that I'm going to do is I'm going to create a spline model. So spline rec, recipe, sale price, data equals tidy train. Okay. We're going to do the same thing where we're just going to do step near near zero variance. Since we know that step correlation, step linear combination won't do anything, I could just remove this, but I figured we'll just leave it in just to make it a little bit cleaner. So we'll do that. Okay. We're going to remove all of the nominal values. So we're only going to be dealing with continuous or numerical data. And then we'll do step BS, basis splines, and we'll say all predictors. And lastly, we'll do a step EO Johnson on the all predictors. Okay. Oops, sale price. Okay, so we have this spline rec. So kind of like a spline or Mars model style. If we do a prep, oh, but there's a fly here. We see that it's doing all this stuff. If we juice it, we can see that we have a decent amount of variables, which might be bad for a linear regression, but we're going to be ensembling, so it won't be used for our last model. Okay, finally, we're going to do a basic recipe. We're going to be adding on to these things. We're going to do a step normalize, so all numeric, and then step dummy, all nominal. Step numeric, and then we'll say minus all outcomes. Okay. So this is our recipe. These are our 3 recipes for some models that we're going to be using. So with our tidy rec, we'll do prep, juice. So essentially this model will be for, or this tidy recipe or like baseline recipe will be used for our more stronger black box models, such as our like a RandomForest or an XGBoost. Our spline and PCA models will be used with these simpler like linear regression models. Okay, so we basically have 3 types of pre-processings that we're going to use, and we're going to apply it to a few models. Okay, first let's make our Pca regression model. So Pca regression model, linear reg, set mode, regression, which I think it defaults to, set engine to LM. So we're going to do a basic linear model, not a GLMnet or lasso or ridge regression. We're just going to do a basic linear regression. And then we're also going to do another one, which will be our spline regression. We'll just say a spline model. Okay. Then we'll create a random forest model. Rand forest. Min n will be tuned. And trees will be tuned. Set mode to regression. And then set engine to, I'll just do random forest. Okay. Finally, for our fourth model, we'll do an XGBoost model. So a boosted tree. And I'll just tune the learn rate and the trees and the tree depth. And then we're going to set the engine to XGBoost. Okay. So we have our models. One thing that we have to do is set our model controls. So with our stacks package, what we're gonna need to do is actually save the predictions, because essentially it's gonna be using each model's predictions and comparing it to the actual value, and then modeling these predictions as coefficients. So we're gonna do a model control, which will be a control grid. We're going to save our predictions, which will be true. And we're also going to have to save our workflows, which will be true. Because it wants to do these pre-processings to our model. So when we're using our final stacked model, it should be able to do the unique pre-processing for our Pca, Spline, RandomForest, and XGBoost models inside of our model. Okay. I'm also going to do a model metrics function. So we're just going to do the classic regression metrics, so RMSE, MAE, and R squared. Okay, so we have our define models, define tuning control, and I'll say define pre-processing. Okay, and then finally what we're going to do is create our grid. So define grids. So we'll do a grid regular parameters of our random forest model. Our levels will be 3. So with this, I don't like how we are only using one tree, so I'm going to change that. So I'll do filter, see trees is less than, trees is greater than 1. So that way we're doing 1,000, 2,000, 1,000, 2,000. Wait. So I'll call this the, was it Rand Forest grid. And then we'll do the same thing. So grid regular, parameters, XGBoost model, levels equals 3. And I'll say filter, see trees, filter, trees is greater than 1. So we have more than, so we have about 1,000 trees for our minimum amount of trees. And I'll call this the XGBoost grid. Okay, so now we have our grids. And finally, what we're gonna have to do is define our workflows. So we're basically combining all of this stuff. So our models, our pre-processing, and then we're gonna start tuning it, and then giving it, passing it along into a stacked ensemble model, and using that to evaluate on our test set. So we're gonna create our workflows. So workflow, add model, Pca regression model, and then add recipe, Pca rep. We're going to create our spline workflow, add model, spline model, add recipe, spline rec, random forest workflow, Add our models. Give it our baseline recipe, which will be our tidy recipe, and then our final workflow, which will be our XGBoost workflow. So you might notice something. Our linear models should not have any parameters, so that'll be very easy to fit. For our random forest and our XGBoost models, we're gonna have to fit it. Okay. So finally, what we're gonna do is fit models. So for our Pca workflows and our Spline workflows, we're just gonna do a fit resamples. So we'll say Pca res fit resamples. We give it our Pca workflow, our resamples, which will be our k folds data. Our metrics which will be our model metrics. And then we'll give it our control, which will be our model control. Great. And now I'm gonna copy and paste these in. So it'll be our spline res, your spline workflow, our random forest res, which are give it our random forest workflow, give it our XGBoost res, and then give it our XGBoost workflow. Okay, so I'm gonna run this, but I actually already have the results from this sample. So we'll load it in. And actually, it's not fit resamples for these guys. It'll be a tune grid and a tune grid. So these guys don't have any samples, so we're just gonna don't have any parameters to tune. So we're just gonna be fitting a model, and then evaluating on the evaluation or k-folds data. In this case, it's gonna do the same thing as our Pca and splines. We'll also show it trying every parameter grouping in our parameter grids that we gave it. So actually, it'll be grid is equal to XGBoost grid. Grid is equal to random forest grid. I have it. Yeah, okay, rand forest grid. So it'll be rand forest grid. Okay, so we can run this, but we have a file already that I tuned last night. We have our load our data. If you look at our Pca res, we actually have our results right here. Great. So now what we're actually gonna do is working on the actual stack. And with this stack, it's pretty easy. So we just have to initiate stacks. And then we're gonna start adding our candidates. So essentially, since we saved our predictions, we can look at our, was it Pca res? We can do a collect predictions, and we have our predictions, right? It's pretty good. We also have our ID, our row IDs too. So it's pretty easy to say, okay, Pca predicted this. The actual thing is that. Combine all of our model predictions together and build another model to predict sales price given our model predictions. So we'll do that. Ames stack. We'll say stacks. We'll add our candidates. So let's do our Pca res. Add candidates. Our spline res. Add candidates. Our random forest res. Add candidates. Our XGBoost res. So this is actually going to run into an error, specifically with our XGBoost results. And I'm not sure why it's doing that. It's saying list columns. And this is one of the problems with a kind of a new package that's still being developed is sometimes we'll run into bugs. So if I remove XGBoost, it'll fit perfectly. So we have our Ames stack and saying like a data stack with 3 model definitions and 8 candidate members, because our random forest model has 6 sets of parameters that it was tuning on. So with our Ames stack, what we're gonna have to start doing is blend our predictions. And this is basically figuring out what type of combination of models we should be using to make our predictions for our final ensemble model. So what it's saying is, oh, we should heavily weight our random forest model, and we should lower our weight for our spline res. Okay, so once we have that, we can do aim stack blend predictions and also fit members. Okay. So now we're fitting the essentially we're fitting each of our model's predictions to the sales price. So our model saw our actual data, such as like housing, size of rooms, number of bathrooms, and our aim stack is just seeing our model predictions for sales price. So it's not seeing as much features; it's just seeing kind of these summarized features, what the model sees and what it believes the house value is. Okay. It's still running. We'll just wait here. And one thing that I will say is, since we have this problem where we can't add our XGBoost model, I think it'd be kind of interesting to just kind of do the ensembling by ourselves using our models without the stacks package. The stacks package makes it way easier and a little bit more with less code to actually create ensemble models, but it's still pretty easy to make a ensemble model with just base tidyverse functions. Okay. So we finished training. We can see our aim stack. Very good. It says out of 8 possible blending coefficients, the ensemble used 2, using a lasso penalty of this score. So it only used 2 of our actual models. It only used our RandomForest model and our Spline model. It ignored our Pca model, which is kind of interesting. So we have our now we have our final aim stack model. Let's actually do it now in base tidyverse way, or the tidyverse way without the stacks package. If you wanted to do it by yourself and didn't want to work with a package that has a decent amount of bugs. Okay, so first what we're gonna have to do is, given our random forest res and our XGBoost res, we're gonna just collect the best metrics. So we'll say show best, and we'll say RMSE. Okay, and I'm just gonna say slice 1, select trees and min n, and that will be our final model. Okay, XGBoost res, we'll say select show best RMSE, slice 1, and then we'll say select trees to learn rate. Okay, so this will be our random forest was it final param XGBoost, and we'll say final param. Okay, so now that we have our final params, we'll actually start creating our predictions. So we'll say XGBoost res. So now what we have, I'm gonna say finalize parameters and say collect model predictions to stack. So with our XGBoost res, we can actually do is collect the predictions, and we have a problem here. So for example, we've tuned multiple models. So we're gonna have to say is we'll just do a inner join with our XGBoost final param. And it's joining by tree depth, learn rate. So it's just keeping our final models. Okay, we'll select the ID, the row, .pred, and sale price. So this will be XGBoost stack. And then let's do it for our random forest res. So I'll do a collect predictions, inner join, random forest final param, make sure it's joining correctly, which is trees and min n. And then we'll do select id dot row dot pred and sale price. Great. So we have that. I'm gonna also change some things. So I'll just say XGBoost is equal to sale price. So it will say, like, in this case, it'll be our actual prediction is our XGBoost prediction. And we'll call this RandomForest is equal to, sale price. And it's not sale price, it'll be dot pred, and then we'll change that to sale price. Okay, so we're going to change our prediction names to the actual model names. Okay. So RandomForest, and we'll call this stack. And now let's look at our Pca res. So Pca res, collect predictions, select id dot pred dot select dot row. We'll say Pca equals dot pred and sale price. Okay, and we'll call this the Pca stack. Finally, we'll do our spline res. So collect predictions. And then we'll do the same thing. So select id dot row, spline is equal to dot pred and sale price. And I know I could just rename it, but I figured we just kind of make it a little bit cleaner to look at of what I'm actually doing. So spline stack. Okay, so we have our stack, and then we'll create our final stack df. And actually, I don't think we don't need sales price for all of them, so I'm just gonna remove that. Okay. So now let's actually join these together. So XGBoost stack, left join, RandomForest stack, left join, Pca stack, left join, spline stack. And it's joining by our ID and rows. So that way we have the same predictions for the same sale price. And this will be our stack df. Okay, so create ensemble data, create stack data, and I'll say okay, so I gotta clean this. So I'll say create stacks model. Cool. So now that we have our stack df, what we can actually do is just fit a generic lasso regression. So linear reg. So penalty, we'll just say penalty equals 0.5. Mixture is equal to 1. So I guess yeah, we'll just do mixture equals 1. So it's not actually no, it is lasso regression. Okay, so set mode to a regression. Set engine to into GLM net, and fit it to sale price data is equal to stack df. Great. So now we have our stack model. Let's actually look at the coefficients. So we're going to do a tidy. Stack df. And then I need to also select out minus id minus dot row. Okay, so we can look at our coefficients. It did shrink our Pca model, but also it still kept the XGBoost model, and we have our splines. So we can actually change this to 0 if we don't want to completely remove a model. And that's one thing where you can definitely just mix with, using your lasso, your ridges, or your elastic nets for your models. Some common other models you use for stacking is decision trees. So you have decision trees, linear models, etc. Generally, you don't want to go too complex into like an XGBoost or RandomForest, but you can. It just leads to more prone to overfitting, which is very easy to do when you're dealing with always modeling stuff with a lot of data leakage. Okay, so now that we have our final model, let's actually just do our final workflow. So XGBoost workflow. So I'll always say finalize submodels. So in this case, we already have our model. we just need to combine our parameters to our XGBoost and RandomForest workflows, and then we're going to do our last fits. Okay, so XGBoost workflow, XGBoost workflow, finalize workflow, and it's what XGBoost final param, last fit, and we give it our tidy split. Okay, and I'll do the RandomForest workflow while it's training. RandomForest workflow, finalize workflow, give it our RandomForest final param, last fit, tidy split. Yeah, we'll do it for our Pca workflow. Cool. Which will be Pca workflow, last fit, tidy split. And then we'll give it to our spline workflow, spline WF, last fit, tidy split. Okay, so it's doing that. We'll wait a little bit. And these models will be very fast. While it's doing that, I'll actually say predict. I'll say extract predictions from sub models. So I can actually create a list. So Tibble, so models is equal to a list, XGBoost workflow, RandomForest workflow, and Pca workflow, and Spline workflow. I'll say names or model names is equal to C, XGBoost, RandomForest, Pca, and Spline. And then I can do a mutate, and I'll say predictions is equal to map model and say collect predictions. Cool. And I'll say final stack final df. Wow, this is taking a little bit longer than I expected it to take. But it should do it pretty fast. Let's see here. Yep, okay, it just did it right when I check. So we do that. These are just, Pca and Spline, so it'll be fine. Okay, so we have our final predictions from our submodels. Okay, we can select our model names and our pred, unnest pred. Great. What I can do is pivot wider names from model names values from dot pred. Okay. Select minus ID minus dot row. Okay, so now we have these things. What I can do now is actually use our model to predict on it. So I'll just say predict, what was it, stack model, right? It's called, what did I call it again? Stack model, right? So that's our stack model. I'm actually gonna set, say stack final df, and then I'll say, okay, predict stack model stack final df, and I'll say bind calls stack final df. Okay, so now we have our prediction, our sales price, XGBoost, spline. We can also do a pivot longer. Actually, I'll rename to stack is equal to dot pred. So that's our stack prediction. We have our XGBoost prediction, our RandomForest prediction, Pca prediction, and Spline prediction. Convert this to a tidy format minus sale price. And then what I can do is a group by name. And then I can do a forecast metric. Oops, it's a model metrics. Truth is equal to sale price. Estimate is equal to value. Oops. Estimate is equal to value. Okay, and then we'll do a ungroup. Pivot wider, just so we can read it. Pivot the metrics. Values from equal dot estimate. Cool. So what do we see here? I'll do a arrange by RMSE. So our stack has a lower RMSE, a lower MAE, and a slightly higher R squared. And you can see how it beats all of our models and all of its metrics. And that's good because when you're doing predictive modeling challenges, that extra 1% of predictive power can make you win that competition. So in reality, when you stack models, you're not going to get like a 50% increase in performance, but you will get some marginal performance, and that's what many people do in Kaggle competitions. Generally in Kaggle competitions, people are not just using an XGBoost model; they're using multiple models and stacking them together to make a final output. Because you don't have to worry about long prediction times. Say like if you're in a production setting, you just have to worry about exporting out a highly accurate CSV. Finally, let's actually look at our Ames stack model. So if we do our, Ames stack, we predict our Ames stack with our test data. I think our tidy test, right? Bind our columns with our tidy test, select sale price. And then we do a, a model metric. So truth is equal to sale price. Estimate is equal to dot pred. Estimate is equal to dot pred. Pivot wider, names from equals dot metric, values from equals dot estimate. Dot estimate. Okay, sorry about that. And what we can see here when combining with our other stacked model is we actually have a higher RMSE than our XGBoost model, so it does not perform as well as our custom stack model, our custom XGBoost model, but it still has some pretty decent performance. Okay, and you can see how doing the Ames stack using the stacks package was much easier with less data munging. So for all this work right here, could essentially be condensed into a one into a two-liner, right? Because these are a piped-in function. So hopefully hopefully the stacks package improves where we can start adding more models, or I can just figure out what I was doing wrong. But you can see how the stacks package is a nice framework and it really follows the tidy framework of tidy modeling. And you can see how stacks definitely just improves your performance across the board. Usually, it may not increase it by a lot, but an extra 20 minutes to increase your percentage by 2% in predictive power is worth it for a lot of predictive competitions. I know I went over a package that may be changing, but I thought it was pretty interesting in my research for the weekend. So hopefully you guys can do some more modeling and kind of improve your models using stacking or win some Kaggle competitions. But in the meantime, I'll see you guys next week and tidy on.